Today we're going to look at symmetry. Our learning target is I can describe rotations and reflections that map a figure or shape upon itself. And our essential question is how can you tell whether a figure is symmetric? Don't forget to fill in your name, class of geometry, and the date today. So a figure has symmetry if a rigid motion, remember that's like a cutout, a shape that's been cut out with some scissors that we're just sliding, flipping, or turning in any way, so that we can map the figure upon itself. Map just means place. Okay, let's try. What transformations map each figure onto itself? So here's a question. Can you draw a line that divides a figure in half? Let's see, here we have almost a rectangle. So it looks like if I had a line in the center horizontally, the figure would fold into two equal pieces. Also, it looks like if I had a vertical line in the center, could also divide the figure in half. Oh, the smiley face is a little bit different. A horizontal line will not provide a figure, it will not put the figure in half, but a vertical line will. Oops. Let's see if I can't. Well, I think that might be as good as it gets. All right, so when we have two lines, we can call it two lines of reflection. And one line would just be one line of reflection. All right, does the figure look the same after a rotation of less than 360 degrees? Well, with this figure on the top, we want to put in our center point of rotation. And it looks like if I just do a half a turn, then the figure will map or be placed upon itself. That looks about it. Oops. So, looks like we have 180 degrees rotation. And with the smiley face, if we put in a center point of rotation where the nose would be, it doesn't matter how many angles we would rotate. The smiley face will never map or be placed upon itself, except for 360 degrees. But then all figures look the same with a 360 degree rotation. Okay, so here we have reflectional symmetry. So reflectional symmetry is a symmetry for which a reflection maps the figure upon itself. And reflectional symmetry has a line of reflection. Here we have line of reflection. Okay. A figure has rotational symmetry if an image is mapped upon to the pre-image, so the original image, after a rotation of less than 360 degrees. Okay, example 1. How many lines of symmetry does a regular hexagon have? Well, let's see. If I just start playing around with lines, maybe I start with drawing lines through the vertices. So from point to opposite point. And there I get 3. So each line through opposite vertices creates equals halves. And just so it wouldn't be overlapping so much, I can also draw in lines that create equal halves through the midpoint of opposite sides. So that creates 3 more lines of symmetry. So 3 plus 3 gives me 6 lines of symmetry. Okay, example 2. Find the angles of rotation that maps the figure upon itself. Okay, here we want to take a look at rotations and angles of rotations. If we remember our rotations lesson, we have a point of rotation, which becomes our vertex. And when we have, looking at the angles of rotation, what we want to do is look at how many vertices there are in the figure. And we can start creating angles. And we see we've got 1 angle, 2 angles, 3 angles, also for our 3 vertices. So we can take 360, because there's 360 degrees in a full circle, divide it by 3, and that gives us 120 degrees. So 120 degrees is one of the angles of rotation, but we want to find all of them. So 120 degrees is one of them. If we keep adding 120 degrees or multiples of 120 degrees, we can find all of the angles of rotation that are less than 360 degrees. Okay, so 120 degrees and 240 for our equilateral triangle. For our parallelogram, if we have one center of rotation, because the parallelogram is not a regular polygon or is not perfectly symmetrical, we more just have to turn the image. You can do that mentally, or you can turn it with your piece of paper to see how the figure could be placed upon itself or mapped upon itself. And in this case, we only have 1/2 turn of 180 degrees. Okay, example 3. What type of symmetry does each figure have? So far we've covered reflectional and rotational symmetries could possibly map a figure upon itself. And our first figure almost looks like a flower or a geometrical flower. And even though it seems like we could maybe, where'd it go? There it is. Even though it seems like we could maybe have a line here, we see that each petal is not perfectly symmetrical. So there actually is no reflectional symmetry. It does appear to have rotational symmetry. If we look at our center of rotation and how many vertices there are, there's 1, 2, 3, 4, 5, 6. So we take 360 divided by 6 gives us 60 degrees. So we know for sure there's a 60-degree angle of rotation. But that's not the only angle of rotation. If we keep adding 60 60 plus 60 gives me 120 degrees, plus 60 gives me 180 degrees. We keep adding 60, we get 240 degrees. Also, one more of 300 degrees. So we have 5 angles of rotation. In our figure down below, if we look at reflectional symmetry, there's 1, 2, 3. And if I were to think of this like an equilateral triangle, in this case, we're going from vertice to midpoint. Vertice to midpoint. So we have 3 lines of symmetry. Okay, if we look at our rotational symmetry, our center point would be our center of rotation, and we would take 360 divided by 3 gives us 120. So 120 gives us one angle, right? That's 120, one angle of rotation, right? But that's not the only one. If we add another 120, we get 240 degrees. So there is 1, 2, 3 possible rotations that we could make to have the figure map or be placed upon itself. Right? Here's our U-try. So we're looking with lines of symmetry. Try and draw in as many lines of symmetry as you can. And question number 2, how do you know whether you have found all the lines of symmetry? Well, there's a clue. If we go back in our notes, everything that you need is in your notes. So we see example 1 in the U-try that also has an example 1, and it gives us clues here that you can draw a line through opposite vertices and through opposite midpoints. Okay, great. We'll see you in class. Just try all of the U-try problems, and we will start class with those tomorrow. Thanks.